Okay, so there are two methods for this question. So I'm going to go through both, and it will be dependent on which your teacher is going through with you. Try to use the one that you are using in class, or if you're struggling with that one, then maybe look at one of the others. Okay, so method number one is using the triangle method. So if I just start off for a minute with considering the graph of sine theta. So if sine theta is 5/13, so if we draw a line across here, if theta was there or there, that's 5/13. So we know that there are two possible angles here, there or there, where sine of the angle is equal to 5/13. We also know that there's two angles over here that would give me minus 5/13. Okay, so when we're doing this method, we are really sort of ignoring the sign of this thing over here initially, on the basis that there are four possible angles that could return a value of plus or minus 5/13. Okay. Now initially we're going to assume that we're looking at this angle here, the acute angle. And because we can assume that, we can use that to draw a right angle triangle. We can't do that with any of the other three angles because you can't have a right angle triangle with an angle that is bigger than the acute angle. So if this is a right angle triangle, and this is, we'll call that angle x, and sine of x is equal to 5/13. So I'm deliberately calling that x and not theta for the purposes of the right angle triangle. So because it's a right angle triangle now, we can use SOHCAHTOA. So if we use SOHCAHTOA, then the 5 is the opposite side and the 13 is the hypotenuse. So that is 5 and that's 13. So we can use Pythagoras then to find the third side, this one here. So a squared plus b squared equals c squared. So 5 squared plus b squared equals 13 squared. So b squared equals 13 squared. Take away 5 squared. B squared is 144, so b equals 12. So that's 12. Okay, now we can use our right angle triangle to work out what cos x is. We need cos theta eventually, but we're going to start with cos x. So cos x is equal, using SOHCAHTOA, to adjacent over hypotenuse, which in this case, so the adjacent side is this side here, the hypotenuse is that side there, so that is 12 over 13. Now, if we go then to the graph, so the graph of cos of x looks like that. So again, we're considering that cos x could be plus or minus 12/13. So for the purposes of this activity, we're going to consider all four of the possible values, the positive and negative values of 12/13. So this is where it's positive 12/13 and this is where it's negative 12/13. Now this is where the method kind of comes together, because we have used the acute angle for the purposes of being able to use the right angle triangle. So we've used the right angle triangle, and that has, in both cases, because we know that cos and sine is positive, and we know that we can only use a right angle triangle where the angle is acute. But we then go back to the question, and it tells us that theta is actually obtuse. Okay, so in our triangle we've used angle x because that is not theta. Theta is obtuse, whereas angle x is acute. So now what we're going to do is we're going to go back to what we've got here, and we're going to rewrite that as cos of theta. So theta can be one of these four angles. It can be that one, that one, that one, or that one. Okay, so now because we know that theta is obtuse, so theta is obtuse, which means that the actual size of it is between 90 and 180. There's only one of these four angles that is between 90 and 180. So that's 90 and 180, so it must be this one here. So that must be angle theta. Oops. Let's do that in black. So that must be angle theta, and therefore cos of theta is negative 12/13. So cos of theta is negative 12/13. Okay? Right, method number two. So method number two is using the identities. So the question told us that sine of theta equals 5/13, and we're trying to find cos of theta. So we know there's a connection between cos and sine. That connection is determined by the identities. Sine squared theta plus cos squared theta equals 1. So, sine squared theta is the same as sine theta all squared. Cos squared theta is the same as cos theta all squared. So if I replace sine theta with 5/13, and then we can square the 5/13, so 25 over 169. And then we can rearrange this whole thing. So cos theta all squared is equal to 1 minus 25 over 169. So that's 144 over 169. So cos theta all squared is that. Now cos theta then is equal to the square root of 144 over 169. And at this point, if we put plus or minus, because it's a square root, so cos theta is equal to plus or minus 12 over 13. Right, now we need to determine whether it's the plus or the negative value. Now, this last bit is really the same as what we did in the first method. So we go back to our cos graph, and we know that theta is obtuse, so we know that theta is going to be between 90 and 180, which is here. Because that is negative, we know that cos theta must be the negative answer, so negative 12/13. Okay.